Artificial intelligence and machine learning have been in the forefront of newspapers over the last several months, especially after the inception of ChatGPT. The public, those who don't even know anything about programming, are really excited about the possibilities of how these new technologies can influence the way we work and enable us to make more informed decisions. I've worked on projects related to AI and ML for a long period of time throughout my career, and even within the real estate space. However, some of these projects I haven't shared yet because there was low amount of interest. There was more interest in how to obtain data and how to automate processes. But now with the hype, I am introducing some previous work that was done, and this is part 3 of a 3-part series. In this video, I'm going to show you how you can train an NLP real estate model to create a supervised model that will help us to detect whether a property has a description that means it's a distressed property, so it needs work, or it's turnkey ready, so it's not distressed. We are going to use ML Flow to be able to help us track our models as well, and Lime for explainability. My name is Ariel Herrera, your fellow data scientist with the AnalyticsAriel channel, where we bridge the gap between real estate and technology. If you want to see more content like this, AI, ML driven with real estate data, please let me know in the comments below. As well, like this video and subscribe so that we could reach a wider audience. All right, let's get started. The purpose of this video is to complete the mini-series that we have of going through a project of how we can classify properties, property listings, as to whether they are fixer-uppers or they are turnkey ready. The phrases that we are using are distressed and non-distressed. So a distressed property could be one that needs maybe kitchen work, the cabinets are outdated, possibly needs new paint. And why would we even care about these older or potentially neglected properties? Well, fixer-uppers or house flippers typically look for these properties because they can add value to them. When they add value, they're able to then sell the property for a higher price. As well, buy and hold investors like BRRRR investors also look for properties that are distressed because they can acquire the properties for a lower cost, have higher returns at the end of the day. But the main problems that investors have is, how do I actually find these fixer-uppers? One of the ways is by looking at images for listings, as well reading the descriptions. Sometimes the descriptions will tell us really good information, like this house needs TLC, tender loving care, or this property needs a new roof, or maybe it is sold as is. These are some keywords that help us to identify instinctively as humans whether the property needs work or not. Now the question is, can we eliminate the need of having to read or scour through these images on our own, as this can be very time consuming, and in real estate, speed is everything. So the use case here is to use a machine learning model to be able to detect for us whether a property is rehab or it is turnkey. And we're going to complete this analysis here by developing a supervised model. As a precursor, this is work that I collaborated with 2 other data scientists that I met off of Bigger Pockets Forum. It was a pet project that we had, and we were able to learn so much. However, there may be some more updated ways to be able to solve this type of problem, and I'd love for you to share in the comments below as we go through the video. So this is prior work that I have not touched in years, but I'm going to give my best effort as to a recap of what work was done and how you could maybe build off of it in the future. So right now I'm on Google Colab. Google Colab is a free notebook environment where you can work with Python without having to have it installed at all. You could also easily share your code with others. So here, if you wanted to start with this notebook, you would come to File and save a copy in your own drive. Now I'm going to walk through the steps that I took. We just went over the use case, and now we had some training data set that we were able to obtain from the last 2 notebooks. So the first notebook was hard coding labels based on the data that we received for descriptions for property listings. The second was using an unsupervised model to better reclassify these listing descriptions, and we had some insights. We realized it wasn't as simple as distressed or not distressed. There are some properties that kind of fit in the middle in that they were maybe in hotspots. So a lot of keywords that we were seeing were city, downtown, etc. And these are things that allowed us to start to understand a data set a little bit better. But in this case, we have a large training data set and we have a lot of unlabeled data. We need some help to build a model on, say, just the small training data set that we have so that we can now try to classify the rest of our data and have a more performant model. So in this, I'm going to use MLflow for tracking and visualization, as well as Line that will help us to understand and interpret the decisions made by our model. So we are installing these packages and then we are importing them. So we have a variation of data transformation libraries, NLP, which stands for natural language processing, as this whole project is about reading text and interpreting it via a computer. Then we are reading in ML related libraries, Lime, and we're going to be using Plotly for charts. Similar to our prior work, we are downloading stop words that we could remove some stop words that aren't really that important for our corpus. We also have similar pre-processing steps that we took previously. And I'm reading in my training data from GitHub. In total, there's about 12.6K amount of rows, with many of them being unlabeled, because as we were going through this human label process, the three of us, we realized, wow, this is just very time consuming and not as intuitive as we had initially expected. So we have a lot of data that is unknown and we'd like to classify with a model. So here we are now filtering down on our data set and only looking at those records where we have labels, where we have a description and we've already labeled it as either distressed or not distressed. Then we could look at some of the original text. What does this data look like? So this is an example of a property listing that has a description that is very distressed-like. So let's read it. Calling all investors, hint, hint, home sold as is. This is a nice split-level home, cornered lot, which is spelled incorrectly. Great investment property, just needs some TLC. Instinctively as a human, by reading this, there's some keywords that stand out, and we immediately know that this is a fixer-upper. This is some of the data that's in our training data set. But as we see, our training data set is not perfect. It's not cleansed right now. We have punctuations. We have words that need to be lemmatized. So for example, if we have a word like fixer, fixing, fixes, this is all going to be separate vocabulary in our corpus, and we don't want it to be too wide. So that's why we're going to use lemmatization as well in our pre-processing step to truncate that to say just fix. So down below, we're processing our text, and now we're going to start into developing our machine learning models. So what's really neat with scikit-learn is that we could use pipelines. And this could allow us to iterate basically through different models. So instead of just training one single model, we could train several. We could even stack these to use multiple models at once. In this use case, we were looking to evaluate different models, and we use TF IDF vectorizer for our bag of words, including decision tree, random forest, XGBoost, and we are using MLP, which is a deep learning model. This stands for multi-layer perceptron. So we have our training and test data set, and once we start to work through each of these models, we are starting MLflow, and we are saving down, so auto-logging our data to MLflow. And how we want to evaluate and compare these models to one another to see which one is more performant is by looking at different metrics, including accuracy, F1, precision, and recall. Note, I am moving quickly through this tutorial because this is previous work that I've done, but if you'd like to really dive into the AI ML space and would like me to possibly make a course on this, I am open to it, but there needs to be enough interest. So please let me know in the comments below if you'd like a zero to hero related course for machine learning and artificial intelligence with Python, specifically for real estate data. So once we go through this, we have all our models that are trained, they're being saved to MLflow, and now we could view MLflow, which is created by Databricks and open source, within our URL that is just for us to view. So here I could see all of the runs that were created. And if I were to click one of them, I can look at the model that we have. I could get the exact version and how this was run. We can also look at more interesting information like the metrics. But out the gate, we can compare model metrics and have everything in one place in a friendly UI without having to fumble between dictionaries or using CSV files. So I highly encourage you to run this yourself, set up a quick ngrok free account, and then be able to look at MLflow as well. But overall, when we were going through cross-validation, we saw that the model that took the longest time to fit, but was the most accurate and had the highest test recall, was the AI model, so deep learning model, multi-layer perceptron, which is also the most black box model, where it's harder to understand why the model made a certain decision. So instinctively, at this point, we've said, okay, we have our training data set and our test data set. We've trained a series of classification models. We've compared the performance to one another. And now we want to go with MLP. But we need to understand why it's classifying certain observations as either distressed or not distressed. And we don't really have insight yet, which is where we're going to use LIME for interpretability. So here I have a quick visualization of which model had the highest performance, which ended up being the MLP model as we discussed. Then we could also do a grid search to get the right parameters that we want to have the best model possible. But I really want to detail a little bit more to LIME. Awesome. So whenever you complete building a model, you always want to observe what didn't get classified correctly, right? The false positives and false negatives. Because in fact, by looking at these observations, you can start to uncover what your model did correct or incorrect and start to tweak it and improve it. So in this case, I have LIME set up, which I have a link here if you want to dive deep into LIME. And here, I am looking at what was classified as a false negative. So in this case, we have our model that stated that this description was not a rehab, so it doesn't need any work because the prediction probability leans towards 0, which is not distressed at 0.51, but it's borderline. So as you could see, there's some words that gravitated towards distressed, some words towards not distressed, but ultimately, let's see if we made the right decision or not. So let's look at this description on the right-hand side. It says, great Henderson opportunity, dual floor plan, formal living room, and then now we start to see blue words that are highlighted in dark. And this is to signify a non-rehab property, so for one that doesn't need work. Ceiling fan, mirrored, and doors. Not sure if we want those words to really be the deciding factor of if a property is distressed or not distressed, but let's keep going. So towards the bottom, we see here, needs TLC, lots of potential. Wow. Instinctively, as a human reading this, I know that this is not a property, it's turnkey. This actually is a property that needs work. And they're saying here, it has a lot of potential. They push this to the very end of the description. So they kind of make this property seem to be really nice, great floor plan, has ceilings, high ceiling fans, but in actuality, it needs a lot of work. And our model did not classify this correctly, as it classified it as a non-distressed property. So some things I'm noting mentally is that one, it's not giving enough weight to needs TLC, for example. Maybe needs is being removed from my corpus because it's a stop word, something I want to look at further. Or maybe lots is also being removed. But if we were to split these to bigrams and trigrams, so needs TLC, that's an obvious way to know that this is a distressed property, as well as a trigram, lots of potential, another obvious way to identify that this is a rehab. So this would now give me some clarity as to how we can improve possibly the training data or how we're setting up this corpus for our model so that maybe it can do better on these types of descriptions. Now let's look at a false positive. So this is an example of where the model classified as rehab, so it needs work, but in our training data set, it says, no, this does not need work. So let's read this description here. Investment property currently rented per month, recently renovated, and professionally managed, terrific street step, right in cash flow, lease, runs until January, HR notice required. 4 showings. So there's a little bit of variation here. We see investment property, so that may make us think, oh, it's a property that needs some work. But in fact, no, it's a turnkey investment property. It's ready to go. It's recently renovated and it's professionally managed on a terrific street. So in this case, our model is actually incorrect. And even though there's a heavy weight towards renovated, it's not enough to make the model classify that this description should be a non-rehab. So these are another observation that we can go back to how we're setting up our data and see if maybe we need to actually just feed in more examples with renovation to help our model to learn that this should really be classified as not distressed. And to sum it up, we have one more example. This is something that our model got correct. It said that this was not a rehab, not a distressed property. And if we look at this description on the right, it states text like great home, great for your kids, new paint throughout new carpet, and new luxury vinyl planks. A lot of new, which helped the model to identify that this is likely a non-rehab. So the probability of rehab was 0.12, rather low, and the classification would not be for rehab. In summary, I know I walked you through this notebook rather quickly as it was a prior fun project I got to work on by collaborating with 2 other data scientists I met off of Bigger Pockets. And not only were we able to expand our technical skills off of this project, learn about real estate data, but we also got to build our network by working with one another. So I highly encourage you to join the Tech and Real Estate Facebook group in the link below, where it's specifically for those who are interested in real estate and technology. Now, you don't need to be a programmer to join the group. You could just be someone who's interested to learn about what's going on, or maybe you have an idea and you want to pair up with an engineer. It's a perfect space for that. And if you're working on a certain project, I would love to hear what that project is and possibly have it featured on the channel. So feel free to leave comments below or reach out to me directly at Ariel Herrera, AnalyticsAriel.com. Thanks so much for watching this mini series, and if you want to see more like it, again, leave comments below, and maybe in the future I'll create a course to take you from zero to hero as well. Thanks.